share you the screen working practical first. So essay number one. Before we start essay number one, first review stuff. So yeah, characteristics of a when yeah, characteristics of master and project partners. Third one is exactly master with P and SC75. So we have both the good work for IC75, then single to semi will converter with R and RL. Then three-phase semi converter that is with R. Single phase PWM bridge inverter for RL. Then next one is to find the load and line regulation. The switch load is one of the regulator. So we have to find out the load line regulation of this. Then we have one practical on simulation software for using power seed from the simulation of three-phase semi full converter R and R. And last one is one of the case study that is HVDC transmission system or photovoltaic system or wind generator. So we have one setup for wind generator system. So we will see the case study of wind generator system. So first one, the PEA characteristics of MOSFET or IGBT. So we'll go for MOSFET. Now the aim of our practical study the characteristics of MOSFET, that is metal oxide semiconductor filter. The requirements: experimental board, indicator, wires. One more requirement is DC power supply, that is for it as well as for the anode or maybe a drain. Third, that is objective. Why we perform this practically and why the university has given this practical? Because we all are very well known about these components in the first year or year, but the behavior of these components under different work condition or voltage or current that we have to observe. This behavior of these components is basically shown in a graphical manner that is called as characteristics. So characteristics basically help us to uh, use the device in a defined or predefined values. Then whatever different conditions, the behavior of that device, we can identify, we can maybe know with the help of its characteristics. So we have to learn the characteristics so that we can, characteristics basically is a pictorial representation of behavior of the device under different conditions when it is applied. Okay. So this is the construction of MOSFET. Basically, it's a depletion MOSFET, but we have to learn enhancement type MOSFET. So these three types of FET is extended till SiO2 layer. So the channel is break. The symbol is also given as a depletion MOSFET. So symbol of enhancement, the channel is break. Okay. So construction in which there are three terminals: source, drain, and gate. Substrate is normally connected to the source. So the device working is already we have learned in a theoretical part. Now we will go for the characteristics of this particular device. So to plot the characteristics of the MOSFET, we have a circuit diagram setup like this. So in which we are using our MOSFET device. See, the substrate is connected to the source. Then one power supply called VGG, another power supply called VDD. So we are using two power supply. The range of this voltage is 0 to 5 volt, and this VDD is having range of 0 to 2 volt. Okay. Then we are using 1, 2, and 3 meters. One is current meter ID, that is in milliampere. Then voltage between drain and source VDS in volt, and voltage between gate and source called as a VGS. So we require 3 multimeters, 2 voltmeter and 1 current meter. Okay. Now in this particular characteristics circuit, we are using two resistor R1 and R2. Okay. So to perform the practical, to identify to plot the drain and transfer characteristics of MOSFET, we have some conditions. So initially we are going to plot the drain characteristics. So in which the VGS voltage is a constant. So we should apply VGS equal to say 1 volt, right? So by varying this VGG, we set the value VGS equal to 1 volt, and then we are varying the voltage VDD in a small step like 1 volt, 2 volt, 3 volt, 5 volt, 10 volt, 20 volt, and so on, right? And note down the corresponding current ID. Okay. So this voltage, when we vary the VDD, we will observe the voltage here called as a VDS. So this graph is between VDS and ID, that is VDS versus ID, when VGS is constant. Okay. So that is shown here. So VGS equal to initially 0. This is actually a depletion MOSFET. So depletion MOSFET is also called as a normally on MOSFET. So it can be turned on at VGS equal to 0, but enhancement MOSFET will never turn on at VGS equal to 0. Okay. So as your VGS is equal to 0, right, initial condition, then we are increasing the value of VDD. So observe the voltage VDS and current ID. So in this graph, as we increase the value of VDS, the current ID increases, and after that, this region is called as the ohmic region, where the current is linearly increasing. After that, the current increases slowly. The rate of change of current or increase in a current is slow. So this is called as a square root law region. And after that, the current is constant. Ideally constant, practically the current is slightly increasing. Right? So this region is called as a saturation region. This region is called as a ohmic region. And the region where the current is zero is called as a cutoff region. Right? So in this particular, as VGS equal to zero, you will get a max. Right? Then if I apply minus 1 volt, right? Minus 1 volt to the depletion MOSFET, N channel MOSFET. See, if I apply minus 1 volt to the gate, then what happens? Whatever the holes which are present in the P region, that will attract. Okay, and definitely uh, because of that, the depletion region here will increases, which will reduce the effective width of the channel. So if effective width of channel decreases, it means the current flow through that device also. So it is minus 1 volt. As you increase the voltage, further minus 2, current decreases. You can see here, current on y-axis decreases. For minus 3, it is again decreases. Minus 4 again decreases. And again after minus 4, the depletion region here is touches to the second region, or you can say the SiO2 region, so that the effective channel width is equal to 0, and that time your current become a constant. So after that, your current become a constant. Okay. So here, this is actually a drain characteristics. Now the procedure is given. Connect the DC variable power supply and fix the power supply to the respective terminals with proper polarities and so on. So this is for your reference. Connect the meters, then increase the supply V in the steps of 1 volt with the help of pot when keeping VGS at constant value. Tabulate the reading in observation table and so on. This is the observation table. Drain characteristics. So VGS equal to say any value 3.7 volt, 4 volt, 1 volt, 2 volt. You can apply any value, and then uh, increase the drain voltage and note down the corresponding drain current. Similarly, transfer characteristics. Set the value of VDS equal to 10 volt, 5 volt, or any value, and then increase the VGS in a small tape like 1 volt, 2 volt, 3 volt, 4 volt, and observe the current, that is called drain current. Right? So this is about the first practical. Now, conclusion. That is, it's your part. So what you learn from this, that you can write as a conclusion. Thank you very much. Thank you very much.